For thousands of years, humans have looked at the night sky and wondered if we could ever live among the stars. Today, that dream is no longer distant fantasy. It is a scientific mission. Rockets lift astronauts beyond Earth. Rovers explore Mars. Telescopes peer into the farthest reaches of the universe. But the greatest challenge still lies ahead. Can humanity leave Earth and build colonies on other worlds? Could we survive on Mars, or even beyond our solar system? This documentary will explore the future of human space travel. We will examine the technologies required, the dangers we must overcome, and the profound meaning of becoming a multi-planetary species. This is the story of how humanity may one day colonize Mars and travel beyond. Earth is our home. It provides air, water, and shelter. But it is also fragile. Climate change, asteroid impacts, or global conflicts could threaten our survival. Colonizing other worlds is not just ambition, it is insurance. By spreading beyond Earth, humanity reduces the risk of extinction. There is also opportunity. Space holds resources like metals, rare elements, and even water ice that can sustain life. Colonies could spark new industries and technologies. Most importantly, exploration is part of who we are. From crossing oceans to climbing mountains, humans have always pushed into the unknown. Colonizing Mars is the next frontier in that journey. Mars is the closest world where humans might build a permanent home. It is about 55 million kilometers away at its nearest approach. A one-way journey could take about 6 to 9 months. Several agencies and companies, including NASA, SpaceX, and the European Space Agency, are preparing missions. The Artemis program will return humans to the moon as a testing ground, while SpaceX's Starship aims to carry settlers to Mars. Robotic missions already scout the terrain. The Perseverance rover is collecting samples. Ingenuity, a small helicopter, proved that flight is possible in the thin Martian atmosphere. Reaching Mars will be the greatest voyage in human history. But getting there is only the beginning. Mars is harsh. Temperatures average -60 degrees Celsius. The air is thin, mostly carbon dioxide, and radiation from the sun bombards the surface. To survive, humans must bring technology. Habitats will need strong shielding, possibly built underground, or with thick walls made from Martian soil. Oxygen can be generated by splitting carbon dioxide, as NASA's MOXIE experiment has already demonstrated. Water may come from melting ice beneath the surface. Energy could be harvested through solar panels or nuclear reactors. Food may be grown in greenhouses with carefully controlled environments. Every resource must be recycled. Every system must be reliable. Colonists will depend on science, innovation, and teamwork to endure. A single mission will not create a settlement. Colonizing Mars requires a permanent base that grows over time. The first habitats may be small, supporting a few dozen people. Over decades, they could expand into villages and cities. Local industries would emerge, producing bricks, metals, and fuel from Martian resources. Transportation systems like pressurized rovers and tunnels would connect settlements. Communication satellites would keep colonists linked with Earth. Eventually, a Martian society could develop its own culture, economy, and governance. Colonies may evolve into independent civilizations. Colonization is not only survival, it is the birth of new worlds shaped by human imagination. Reaching and living on Mars presents enormous challenges. Radiation is one of the greatest threats. Without Earth's protective atmosphere and magnetic field, astronauts are exposed to cosmic rays that increase cancer risk. Shielding and new medicines may be needed. Psychological strain is another. Isolation, confinement, and long delays in communication could test mental health. Virtual reality, strong social bonds, and support systems will be essential. Technology failures could be deadly. A broken life support system or power outage would require immediate repair. Colonists must be trained engineers, doctors, and problem solvers. These challenges are real. But history shows that human resilience and innovation often rise to meet them. Mars may be the first destination, but it will not be the last. the moon will serve as a nearby base for training and resource extraction. Its craters contain ice that can provide water and fuel. Asteroids could be mined for rare metals. Colonies on space stations may refine these materials. Farther out, the icy moons of Jupiter and Saturn are intriguing. Europa and Enceladus hide oceans beneath their frozen shells. Titan has rivers of methane and a thick atmosphere. Though hostile, these worlds may one day host research outposts or robotic colonies. Each step outward expands humanity's presence in the solar system. Mars and the outer planets are within reach. But what about the stars? The nearest star system, Alpha Centauri, is over 4 light-years away. With current rockets, the journey would take tens of thousands of years. Scientists imagine new propulsion systems. Nuclear fusion could provide continuous thrust. Light sails pushed by lasers might reach a fraction of light speed. Antimatter engines, though theoretical, could offer even greater power. Projects like Breakthrough Starshot already explore sending tiny probes to nearby stars. For human voyages, interstellar travel may require generational ships or suspended animation. Though distant, the dream of reaching other stars inspires new technologies that benefit science today. Colonizing Mars and beyond is more than technology. It is about vision. It pushes humanity to unite around exploration, innovation, and shared purpose. It sparks advances in energy, medicine, and engineering that benefit life on Earth. It changes how we see ourselves. From space, Earth is a fragile blue dot, a reminder to protect our home while seeking new ones. The future of human space travel is not only about survival. It is about hope. It is about expanding the boundaries of possibility. It is about ensuring that humanity's story continues for millions of years. The journey to colonize Mars and beyond will be the greatest adventure in history. It will test our science, our technology, and our spirit. The challenges are immense, but so are the rewards. By reaching other worlds, humanity takes its place among the stars. Mars is the first step. The solar system is the next. The galaxy awaits. This is the future of human space travel. Astronauts heading to Mars must endure years of preparation. They will train in desert habitats that mimic Martian isolation. They will practice emergency repairs in underwater facilities that simulate weightlessness. Psychological endurance will be tested in long-term confinement studies, where small teams live together for months without outside contact. Beyond traditional training, future colonists may need advanced medical knowledge, engineering skills, and even farming expertise. Each person must be a multi-skilled problem solver. On Mars, there will be no quick rescue from Earth. Survival will depend on the resilience of those who make the journey. Some scientists wonder if Mars itself could be reshaped to support life. This process, known as terraforming, involves altering the planet's environment to make it more Earth-like. Ideas include releasing greenhouse gases to warm the atmosphere, deploying giant mirrors in orbit to reflect sunlight onto the surface, or using massive machines to thicken the air. If temperatures rose enough, ice beneath the surface could melt, creating rivers and lakes. Terraforming remains theoretical. The scale of technology required is beyond our current capabilities. Yet even small steps, such as building domed habitats with controlled climates, represent the beginning of planetary engineering. Whether full terraforming is possible or not, the idea shows the ambition of humanity. We are not only visitors to other worlds, but potential shapers of them. For colonization to succeed, space must support its own economy. Launching every resource from Earth is too costly. Instead, settlers must learn to live off the land in space. On the Moon, robotic miners could extract ice and refine it into rocket fuel. On Mars, factories could process regolith into bricks for construction. Asteroid mining may supply rare metals like platinum and iridium, fueling industries both in orbit and on Earth. Orbital shipyards could assemble massive spacecraft, avoiding the difficulty of launching heavy structures from Earth's surface. Refueling stations near the Moon or Mars would enable deeper exploration into the outer solar system. By turning space into a place of production, not just exploration, humanity lays the foundation for permanent expansion. Colonization is not only about technology, it is about how humans will live together far from Earth. What will a Martian city look like? Perhaps a network of interconnected domes with streets, schools, and theaters under protective shields. Children born on Mars may see Earth only as a distant blue star in the night sky. Over generations, they may develop unique customs, accents, and even biological adaptations to lower gravity. Questions of law and governance also emerge. Who will control resources? Will Martian colonies remain under Earth's authority, or will they form independent nations? History suggests that distant settlements often develop their own identities. Mars may follow the same path. Culture, art, and community will be as important as engineering. To thrive, humanity must carry not only science, but also spirit, creativity, and meaning to new worlds. Some critics ask, why spend billions on space when problems on Earth remain urgent? The answer lies in perspective. Space exploration drives innovation. Rockets gave rise to satellite technology, which now supports global communication, weather forecasting, and disaster relief. Research for Mars habitats advances sustainable energy, recycling, and closed-loop agriculture that can also help cities on Earth. Exploration also inspires. Images of Earth from Apollo missions in the 1960s ignited the modern environmental movement, showing our planet as a fragile oasis in space. Colonizing Mars may similarly inspire humanity to unite in solving global challenges. Space travel is not an escape from Earth. It is a way to better understand and protect it. Space is not kind to the human body. In microgravity, bones lose density, and muscles shrink. On Mars, gravity is only about 1/3 of Earth's, which could reshape human physiology over generations. Doctors and researchers study how to counter these effects. Exercise machines on the International Space Station already help astronauts maintain strength. Future colonies may need artificial gravity habitats, such as rotating modules that simulate Earth's pull. Radiation adds another threat. Cosmic rays can damage DNA and increase cancer risk. Scientists test new shielding materials and medicines to protect future settlers. Some propose genetic engineering, enhancing human resistance to space conditions. Colonization is not just about technology. It may also transform humanity itself, changing our bodies as we adapt to alien worlds. Humans will not colonize Mars alone. Robotic partners will play a crucial role. Machines can build habitats before humans arrive, assembling structures from Martian soil. AI-guided rovers will transport cargo across harsh terrain. Autonomous drones may patrol colonies, ensuring safety and monitoring the environment. On Earth, robots already assist surgeons, farmers, and disaster teams. In space, their importance grows. Distance means communication delays, up to 20 minutes between Earth and Mars. Colonists will rely on AI systems capable of independent decision-making. Together, humans and machines will form hybrid teams, combining creativity and adaptability with precision and tireless labor. Colonizing space is more than survival or science. It is a question of identity. Are we bound to Earth, or are we a cosmic species destined to spread through the stars? Philosophers compare colonization to past human migrations. Just as ancient explorers crossed oceans without knowing what lay ahead, we may cross the void of space for discovery and meaning. Living on another world may also change how we view ourselves. Earth will no longer be the only home of humanity. We may begin to think of ourselves not as Earthlings, but as citizens of the solar system. This shift could redefine culture, politics, and even spirituality. The stars have inspired myths for millennia. Soon, they may inspire civilizations. How soon can this vision become reality? Experts suggest the first crewed missions to Mars may occur in the 2030s. A small base may follow in the 2040s. By the end of the century, permanent settlements could take shape, with hundreds or even thousands of residents. Looking further, lunar bases and asteroid mining may emerge within decades. Outposts on Europa or Titan may appear in the centuries ahead. Interstellar voyages may take millennia. Humanity's story of expansion is not a single event, but a long timeline of steps. Each mission builds on the last. Each generation passes the torch to the next. From the moon to Mars, from Mars to the outer planets, from the outer planets to the stars, the journey is measured not in years, but in eras. If you enjoyed this exploration, subscribe for more cinematic journeys into science, discovery, and the destiny of humanity. If you enjoyed this exploration, subscribe for more cinematic journeys into science, discovery, and the destiny of humanity.